All right. So in this example, it's asking us to how to find the possible number of distinct rational roots. So just remember on this one, guys, that there was two tests that we talked about in this chapter, or at least in this section. It was the rational zero test, which told you the number of possible rational zeros, hint, which we're talking here, and then as well as Descartes' rule of signs. And this was in the last section of that. So when you guys are studying, you'll see the rational zero test and Descartes' rule of signs. So since it's asking us for the number of possible rational roots, all we really need to do that is, if you recall, doing our plus or minus p over q. So q is your leading coefficient, and p is going to be your constant. And remember, it was not p and q. It was the factors of p over q. So that was the rational zero test. So the easiest thing to do here would just be taking the factors of 4, which are going to be plus or, I'm just going to do plus or minus everything. So that's going to be so we'd have 4, 2, and 1. And then we have the factors of 6, which is going to be 6, 3, 2, 1. Right? So that's the factors of p over the factors of q. Then, basically, all we had to do now is match up. Now, I'm going to distribute the plus or minus here. But basically, now all we're simply doing is just taking every single numerator and matching up with every single denominator. Do you guys want me to write out, or do you guys want me to do the simplified version? OK, so 4 over 6 we can do reduces down to 2/3, right? So I'm doing that in my head. Comma, plus or minus 2, 6 reduces to 1/3. So what I'm doing is 4 over 6, wrote it down reduced. 2 over 6, wrote it down reduced. 1 over 6, done. So I did all the numerators over 6. Follow? Now I do all the numerators over 3. So 4 over 3, 2 over 3, 1 over 3. Oop, we already have that, right? So I don't need to repeat it. Do you guys see that? OK. Now let's do over 2. Crap, I'm running out of space. So let's do it over here. So what did we already do, the 2s? No, we can do the 1s. All right, so now we do the 1s. 1 over 6, I already have that. Don't need to repeat it. 1 over 3, I already have that. Don't need to repeat it. 1 over 2, don't have that. Yes?
You repeated 2 over 3.
I did repeat 2 over 3. Thank you very much. So all you do is you take every numerator and put it over each set of denominators. And then we just count, because that's what they're asking is how many. 1. Well, actually, be careful. It's plus and minus, right? Yes? So 2, 4, 6, 8, 10. And therefore, I'm sorry? I forgot to do. Oh, did I like? I would say what? Yeah, 10 is not an answer. So, but did I forget 1 over 1?
Well, it should be 6. 1, 2, 3, 4, 5, 6.
Did I like not write that in there? Or I just like totally forgot about it?
You just forgot about
I just totally forgot about it. So we got more to do, right? We still have 4 over 1. We have 2 over 1. And we have 1 over 1, right? So we have those 2 left, correct? I guess I just like didn't see it. So I had like blinders on. So let's count. 2, 4, 6, 8, 10, 12, 14, 16. And that is an answer choice, which is answer choice C, right? So yeah, just be careful. It's fairly easy like doing it, but you can obviously see how quickly and easy it is to make a mistake.